Who's back? It's another math episode from Mr. Mac. Alright. So we're just gonna continue with task number 5, starting with question number 5. First up, we're looking at the graph on the left. It's all about a weekly newspaper subscription. You'll notice it's a straight line, which means the cost is proportional to the number of weeks. To find the cost for 1 week, we need to figure out the unit rate. Let's look at the points. 4,30, 860, 1290. The y values represent the total cost, and the x values represent the number of weeks. So to find the costs per week, we want to divide the costs by the number of weeks. Let's go ahead and look at the first point, 4,30, and we're going to be dividing our y value divided by our x. And once we do that, we are able to determine that it's going to be $7.50 for the duration of 1 week. So this weekly newspaper subscription is $7.50 per week. Not bad for a subscription, right? Think about how many things you can buy for $7.50 at your favorite snack shop in RVC. Now let's look at the second graph, which shows how a plant grows over time. The goal here is to find how many inches the plant grows each week. Again, the unit rate is what we're aiming for. We'll use the points 2,3 and 4,6, where the x values are the time in weeks and the y values are the height in inches. To find the growth per week, we need to set up the question kind of like how we did the last one. All right, we're going to look at the 2 points, starting off with the 2, 3. All right, we have our y value over our x value, and we have the point 2, 3, where our y value is the second number. In that case, the y value was 3, the x value was 2. All right, and now I just want to take a look at the other one. We also had the y value as 6, the x value was 4, and if I wanted to simplify, it's also 3 over 2. So what we end up finding out is that in 2 weeks, the plant grows 3 inches, but I want to go a bit further, so let's find that unit rate. So if I'm looking at 3 over 2, and we're finding that unit rate once more, we end up figuring out that we get 1.5 over 1, meaning in 1 week, the plant grows 1.5 inches. Yep. So there goes our answer, and that's pretty cool. With this plant growing 1.5 inches every single week, imagine if your plant at home grew that fast. Now let's move on to question number 6, letter A. Now, question 6 says to write an equation to represent each proportional relationship below. So they're letting us know that these are proportional relationships. But before we dive into the questions, I want to point out something super important. Labeling the first column as X and the second column as Y. Let's go ahead and do that. Why do we do this? It's all about independent variables. The first column X is the independent variable. This is what we control or what causes the change. Think of it as the input. The second column y is a dependent variable. This depends on x or changes because of x. Think of it as the output, kind of like in science class. So in question 6, for example, for part A, x is the number of mules and y is the number of bales of hay. Sorry, that just sounded a little bit weird to say because I'm not used to speaking about it. But same thing happened in part B. X is the number of bags of chips, y is the total cost. The total cost depends on bags you buy. And with letter A, the number of bales depends on number of mules. All right, now let's get to the question. Labeling the columns helps us understand how these values are connected and its foundation in writing the equation. So looking at the first table, we're looking at the mules and bales of hay. Remember, X is the number of mules and Y is the number of bales of hay. Check out the pattern. 2 mules, 1 bale, 4 mules, 2 bales, 6 mules, 3 bales, and so on. This is proportional because the ratio stays constant. For every 2 mules, there's 1 bale. To find the equation, think about how Y, bales of hay, relates to X, mules. For every mule, you're getting half of a hay. Let's take a look. So I quickly just set up my setup box, putting the bales of hay over the number of mules, and then I'm just going to try my best to simplify each ratio to show how it's a proportional relationship. So as mentioned earlier, for every mule you're getting half a bale of hay, and Since all simplify to 1 over 2, we can represent that with the equation y is equal to 1 over 2x. All right, and remember that's coming from our proportional relationship equation where k is representative of our constant of proportionality. So we just wanted to substitute in that constant ratio of 1/2 in for our constant of proportionality. Now let's move on to 6b. Now for the second table about chips and costs, again, label the columns. X is the number of bags and Y is the total cost. Done. Check the pattern. 3 bags to $2.25, 4 bags to $3, 6 bags to $4.50. To find the cost per bag, we want to divide the cost Y by the number of bags X. So I'm going to start off with the first set. So once we divide the numerator and the denominator by 3, we end up figuring out that it's going to be 0.75, aka 75 cents for 1 bag of chips. Now we're going to go ahead and do the same thing with the next two situations. Each time we receive a constant ratio of 75 cents per bag, or 0.75 over 1. The cost is proportional to the number of bags. So the equation is y equals 0 or 0.75x. And the last tidbit I want to leave you with is great work, everyone. Always remember to label x and y because it helps you understand which values depend on the other. By identifying the independent and the dependent variables, you can find patterns and relationships much more easily. Whether it's tables or graphs, the key is spotting the constant, rate, ratio, or proportionality. You got this. Proportional relationships are like life hacks for math. Keep practicing, and soon you'll be able to decode these equations like a pro. See you next time, RVC's Finest.